My name is Pedro, and I'm here to tell you a tale about OpenNebula, and more exactly OpenNebula at PTisp. I'm the CTO at PTisp, and I also do a lot of other stuff. You can look or you can read more about what I'm currently doing at Twitter or GitHub. I work a lot with Nodejs and Docker, so we'll talk a bit more about this during the presentation. So, what is PTisp, or what do we do? We are a hosting provider. We currently operate in 2 data centers with about 36,000 domains and 700 virtual servers. So virtualization is a big part of what we do in operations, in daily operations. So what is this tale about? Why do we need a new IaaS? What were the requirements for this new IaaS? Why did we choose OpenNebula in the end? What did we change to make it fit to our use case? And this is going to be interesting, this part. And in the end, what did we give back to the community, which is always important. Okay, so when we start looking for a new IaaS, we already had one, which was based on a turnkey solution. And this was the main big problem, or the main issue. It was hard to add added value product-wise, because it was a closed solution, very turnkey-ish solution. So it was a thing that you buy and you sell exactly like it is, and it's very difficult to build a custom product or a custom scenario on top of it. Additionally, we need more expansion, so we need to grow, and we were having substantial licensing costs with that solution, so it was time to move on, basically. So requirements. I think this is the main 7 ones. Openness, probably the biggest one, just because of what I just said. The second one was very important. We really wanted to avoid a spaghetti stack, like I like to call it. What is a spaghetti stack? Basically a platform that uses multiple languages, multiple coding styles, multiple platforms. It's basically very hard to maintain. It requires a bigger team with different operations areas, so it's very hard. And we have a very small team, so it's a main issue, a main requirement. Low maintenance, low entry barrier. clvm was also a requirement for us because we had some old stuff that we needed to import into this, so it was basically the clvm internal requirement. API for integration and support, just in case something goes wrong. We have someone to help us, which is always important. So this is what we tested. OnApp was what we already had in the first iteration. Yes, let's call it this way. OpenStack smelled a bit like spaghetti. So high maintenance, high operation, required a big team. Was really not a thing for us. And I really like not the previous presentation, but the other one that showed that big truck. It's exactly what we felt looking at it. So yeah, it was not a good fit. Cloud stack, we felt entry barrier bigger than OpenNebula, probably due to the documentation. But we felt at home with OpenNebula. We understood what we were reading. We clearly saw the vision, the roadmap, so it was a heaven match. Open, obviously. it was really easy to adapt OpenNebula. Probably the easiest from what we tested, which is very, very, very important. Low maintenance, as I said, we had a small team, so it's an important thing. Support and really powerful API, which is big, important. It's very, very important for us, and you will see why in a few seconds. So, we had to change a few things, or hack, like you usually say. The first one was clvm. The second one was allowing our customers, or at least allow us to resize the main image, the VM main image. We operate in a market that does not like additional images into the VM, so they are usually expand the VM. It's not a bad or good thing, it's just the reality on that market where we operate, so we had to integrate that, find a way of doing this. OpenNebula currently does not do that. Well, right now it allows you to spawn a custom size VM. At the time it doesn't, but we needed to expand. So after we sell that product to a customer, we need to accommodate his expansion and allowing that VM to grow storage size. Storage-wise. Systems integration was a big thing for us, provisioning, billing, etc. And reselling. So we have a customer type that buys us resources, basically, and then sells that resources to another client using a web interface, API, or whatever. So the first one, clvm. Clvm is hard to maintain, in our opinion. Cluster recovery isn't always obvious, and it should be. It really should be. It had additional moving parts to the equation in the layer that it really is a bad layer to play around. So at virtualization layer, we can just swap things really fast and really quickly with minor downtimes. At the storage layer, things are more critical and hard to replace or to just recover. So it's a layer where you want to be agile and keep things simple and avoid additional moving parts. So clvm was a no-go for us since the beginning. We tried a lot. We had problems with fencing. In the beginning, due to our cluster size was not big enough. It was a nightmare, to be honest. So we started looking for a solution to this. We didn't reinvent the wheel. Other platforms are doing exactly what we have done. So we had two problems that clvm was solving if it was working properly. Volume sanitization, so avoiding data corruption by having the same volume active and mounted or written or modified in two places at the same time. And keeping the volume directory clean and sane. So having volumes active where they need to be and inactive where they need to be also. So what we ended doing, we modified the FES LVM drivers, basically making sure that a volume is active where it needs to be. So in the host it needs to be, and inactive or deactivated in the host where they are not needed anymore. Giving you an example, a live migration. So we tweak the pre-migrate and post-migrate scripts. This is just an atomic example, but it's the best one. On pre-migrate, we activate the volume at the LVM level. the migration completes, and then the LVM is deactivated on the source host. Like I said, we didn't reinvent the wheel. This is done in other platforms. We just copied this algorithm or this behavior into OpenNebula. It works pretty well. It avoided us running clvm, and it kept things pretty simple, which was awesome, and so far so good. Additionally, we wanted to make sure that things were really working at this level, and making sure that wherever there is human intervention, things are left like they were before. Before that human intervention, we giving you example, a VM needs to be recovered for some motive. A customer just messed up with the file system or something. If a system administrator goes to a host or something like that, inspecting the VM image or just mounting it, we want to make sure that that VM stays sanitized, that it stays all right, everything was like it was before. Because of that, we developed a thing that we call the janitor. Basically, janitor is like a bot that connects to OpenNebula API and then connects via SSH to each host and fetch all the data from the API, the logic data, basically the metadata, and then fetch real data from the hosts, basically LVM data, Virch data, virtualization data, and then cross-matches them, making sure there's no ghost VMs that exist in the host that does not exist in the OpenNebula, or a volume that's active in one host that it doesn't need to be because the VM is running on another, things like that. Usually it does not find anything, but you never know. And the human part of everything is always a problem. We also use it as a boilerplate for other crazy things we do, because it's a real small project that interacts with the infrastructure at SSH level and then interacts with OpenNebula at API and puts everything together in one place, which is awesome. So you have logic and real physical data on a single place. This is written in Nodejs, so we'll talk about that later also. So the second point, or the second thing we had to accommodate was image resize, main image resize, I mean. So we have, in order to do this, we leverage libguestfs a lot, really a lot. libguestfs is like awesome. So basically we developed this strategy. We stop a VM, we create a new volume with a specified new size, so a bigger size. We only allow expansion for now, which is safer. We copy the old volume into the newer one. We expand the internal file system. We rename the old one into something under -old or something like that, and then rename the new one into the old one name. And we start the VM. So basically the original volume is left untouched. This is a requirement for us. I know this wastes a lot of space because the old image is left there. But at the same time, we sleep better because the original data is there. It can be deleted after a few days, after a few months. In case of disaster recovery, we always have that data before the expanding operation. So this is a big thing for us. This could be done a different way, expanding the original volume without copying this information. It should be faster, obviously, and waste less space, but yeah, it's a trade-off basically. A big issue with this is that we have not integrated this into OpenNebula, to be honest. So all this is done in a different path at the host level. not at host level, not at low level, but the Sunstone is not aware of this, for example, and all the other metadata. So this is a kind of an issue. The third point was the Nodejs add-on, well, which ended in the Nodejs add-on. Basically, we need to talk with OpenNebula, integrate OpenNebula using its API. So we developed a wrapper or a driver, Node.js, that implemented all the endpoints from the API, which we used in Janitor and all that stuff. I think, I have not checked the last version, but I think .12, it implemented all the endpoints. Test coverage really needs some love. So if someone wants to help, it's welcome. We developed this internally, and then someone, I can't remember who, from the OpenNebula asked us if we want to donate it, and then we donated it to the OpenNebula GitHub organization, and it's there for everyone, and it's open source as usual, so it's awesome. And contributions are always welcome to help. Giving you a little small example, the colors aren't great for this. Wow, there's a 12 in there, it's the VM ID. So giving you an example in Node.js, so you get the VM object. Again, this is a 12, you can see it. Querying the VM for info and doing an action. So it's the API, it's the usual stuff for cloud. It's the same API from Dockerel, if you know it, and other stuff. So it's pretty simple and correlated with the API and the API documentation. Okay. The next point is something we never shown to anyone. We are showing it for the first time today. I'm not sure how I'm doing with time. So I'm pretty excited about it. It's it touches that point about resellers. So that problem we had, we needed to sell resources to a customer that in the end will sell it to another customer and so on. We could do that in the Sunstone, but we prefer to keep the Sunstone for us and abstracting this iteration with the client to another more upper level stack, let's call it this way. So, using the Node.js add-on, we developed something that we called clvm.1. The name was not easy to come by, so I hope you like it. It's basically a web panel written in Node.js that leverages the OpenNebula API using the Node.js add-on. So it does some cool stuff. I will show you. It abstracts that low-level feel that we feel and we need in Sunstone to a more DigitalOcean-ish feeling. That feeling that you create a VM and okay, and things just happen magically. It's multi-tenant, so you can create users inside it and define resource plans or billing plans to these users. It has an optional built-in ticketing system. This is like a freebie, to be honest. And yeah, and you can limit resources at the OpenNebula level, and these resources are also per instance of Clouddash. So you can spawn multiple Cloudashes using the same OpenNebula instance, using different users in OpenNebula. This is a regular user. I think I have this already. This is the last slide. It doesn't need at all one admin or something like that. It was not designed to work like that. it implies VM ownership at the Clouddash level and then at the open level because it uses a specified user for that. Allows network manipulation, basically everything that you have at the Sunstone level. Console was a funny one because right now OpenNebula does not have an endpoint to operate the console. So I'm laughing because we are scraping OpenNebula, fetching the ID, the temporary ID, the security ID from the Sunstone, and then connecting using no VNC just like Sunstone does to the instance. So we are basically copying the behavior of Sunstone, leveraging the security ID from it. So I hope this works in future versions. Probably it will not, but in the future version, more likely console will be in the endpoint, API endpoint, so everything will be more pretty. So let me just show you a quick demo of this. You can check all this, the code is open source as usual. The link is clouddash.one. The GitHub repo is here. There are instructions that need to be improved, but they work. Sorry, it's not this. They work. There's a config file that specifies the OpenNebula hostname and the user you want to use, and resource limit that will be shared between all users using that Clouddash instance. So, giving you just a quick overview of this. I'm not sure if I have internet. Okay. So it's, like I said, digital ocean-ish feeling on top of OpenNebula, just like I described it. I can't describe it better than this. So the usual stuff that is also in Sunstone, but in here in more final user feeling-ish. So console statistics and everything. We didn't implemented the expansion thing that we did for our own because it's not an OpenNebula thing. We want Clouddash to support everything that OpenNebula supports by default without hacks. So everyone in here can just grab it, use it, and it will work without hacking your OpenNebula instance. If you want, you can, but by default, it just works. So I'm not sure why it didn't connect, but my internet is very connecting, disconnecting. So options and all that stuff that you normally use. So, and one more thing, there's logs. These logs are Clouddash side, and then there will be logs also in OpenNebula from the user you are using. And that's it. I'm out of time. So if you have any questions, go ahead. And it's everything. So questions, if anyone have one.
Yes, it's a question about this interface. So you build this on top of OpenNebula, and what about the support functionality? Are you using any third-party component, or do you build your own?
It's really freebie, so it's basically a very simple ticketing system that we build.
You build the ticketing system,
yeah.
So
it's really optional, so you can really just at the options disable it, basically.
So it's a way to communicate the user with the admin of the cloud.
There's when you do npm installing the Clouddash, it creates the default user, which is admin, and then the admin creates other irregular users, and so there's a superior user or the admin users and then regular users that each one has their billing plan and stuff. Yeah, the admin responds to tickets, the users create them, and the usual stuff.
Yeah, that works. Yeah.
Yeah, it's really simple. It's like an email in the browser, to be honest. Yeah. So, but with a status, open, close, the usual, real simple ticketing system. This is a very small thing we built, but that we think there's a lot of potential in here. That because it's simple, it's mainly JavaScript client-side and JavaScript, the server-side with Nodejs. So, and leveraging the Nodejs add-on from OpenNebula. So it's very OpenNebula-ish of doing things, in our opinion. So I think it's great.
Thank you.